in this problem, we have a car. It's a very similar to the problem you had with a box sliding across the floor, except this is easier. We have a car. When you use the brakes on a car, you're actually using friction to stop the car because it's the brakes, pads, sliding against the disc that brings the car to a stop. And so you're doing work with a non-conservative force. So here you have a car of 1511 kilograms. You know how fast it's moving. How much work do the brakes do in bringing the car to a stop? Let's take a look at this. This is conservation of energy. And one thing we already know, the potential energy at the beginning of the problem is 0. Potential energy at the end of the problem is 0. Both of those are 0. Also, at the end of the problem, we'll come to a stop. And so the kinetic energy at the end is 0. That leaves us with just kinetic energy at the beginning plus work due to friction, and that has to add to 0. Well, work due to friction is minus KE1, which is going to be minus 1/2 mv squared. Now we can stick this all together. 1/2, the mass, 1511 kilograms, the velocity, 22.7 meters per second. Squared, let's calculate that. We have mass of 1511. We have a velocity of 22.7. And so the work from non-conservative forces is minus 0.5 times 1511 times 22.7 squared. So minus 389, 302 joules of work has to be done to bring you to a stop. Now, why is it negative? Because the work being done opposes the motion. And since it opposes the motion, the work being done is in the opposite direction from motion, and therefore the work is negative.